Hi everyone, my name is Rahmadi again. Today I'm presenting our work OVRseen, which is a system and framework for auditing network traffic and privacy policies in Oculus VR. This is joint work with Hieu, Janice, Anastasia, Shuba, and Athina Markopoulou. Virtual reality is a newly emerging technology that has great potential and a wide range of applications from games to education and healthcare. And Facebook, or currently called Meta, is one big proponent of this technology through Oculus, or in particular, the Quest 2 headset as one of the most popular VR headsets. When we're using the VR headset, we are using a VR app, and we're interacting with the VR environment in the app. For example, when we are using the Beat Saber game, we are following the beat of the music as we are tasked to slash the red and blue boxes that are appearing in front of us using two lightsabers in our hands. In the real world, however, the VR sensors on the device may collect body and motion data on top of other data that are probably being collected as well, such as personally identifiable information or PII. On-device ads are also coming. They can be immersive and use sensory and biometrics info. Further, we don't know exactly what data are being collected, by whom, and for what purposes. And so VR is the next big thing, but its privacy implications are not well understood yet. The research community has been looking into privacy in various platforms. In particular, there have been works, including our own works, that look into tracking and data collection in various edge devices by looking into the network traffic to understand what data types are being sent to which destinations. For privacy in VR, there have been works on user study and body motion data analysis. And our work, OVRseen, which I'm presenting today, is the first work on auditing network traffic and privacy policies in VR. At the systems level, multiple apps can run on a platform, and together they send data in the network traffic to various destinations. Meanwhile, in the privacy policies of apps and platform, they describe the data collection practices as mandated by privacy laws such as the GDPR and CCPA. In the context of our work, auditing means checking the consistency between the data collection practices that are actual in the network traffic and the declared practices in the privacy policies. To enable this, we adopt an existing framework that's called contextual integrity that is meant to assess the appropriateness of information flow according to its transmission principle. Information flow consists of sender, data type, recipient, and subject. Sender can be the app or platform. Data type can be PII. Recipient can be first or third-party destination, and subject is typically the user as a data owner. Transmission principle is basically the context for the flow, which can be the purpose of data collection and other contexts, such as notice and consent. Together, these elements form a tuple. In this work, we focus on these four elements as we exclude the subject, which is typically the user, and we focus on the purpose as a transmission principle. So suppose we wanted to audit the Beat Saber app, and we could extract the tuple elements from the network traffic. We call this on the network traffic side as data flow. In this example, the data flow consists of Beat Saber as a sender, user ID as data type, Beat Games as a first-party destination as a recipient, and so we infer that the purpose of the flow is most likely for functionality. Suppose we could also find a corresponding collection statement in a Beat Saber's privacy policy, and we could extract the same tuple elements. In this example, we can see that the tuple elements extracted from both sides are consistent. To summarize, auditing means examining the data flows from the network traffic, analyzing the collection statements from the privacy policies, and checking the consistency between the two. In VR, we enabled this by creating and using OVRseen. So let's take a look into OVRseen in more detail. The first part of OVRseen is network traffic analysis. We start with collecting 150 most popular paid and free apps from both app stores, namely Oculus and SideQuest, as the most popular third-party app store. We run each app on Quest 2 headset for approximately 7 minutes as we interact with the app. Meanwhile, we use nMonitor, a VPN-based decryption tool with no routing, to collect and decrypt the network traffic. We also use FRIDA to perform certificate validation bypass. It is a dynamic instrumentation tool to allow the certificate of end monitor to be trusted by the system as it performs the decryption. Here, OVRseen makes a contribution in the decryption part. The research community is familiar with JVM-based techniques for FRIDA, in which the validation function can be found in a symbol table on the JVM stack trace. However, on Oculus, OVRseen deals with strip binary, which has no symbol table, and so it has to perform binary analysis. If you're interested in more detail, please check out the paper, or you can ask me questions as well. Upon collecting the network traffic, we post-process the trace, and we extract data flow, which consists of app or sender, data type, and destination or recipient. Overall, our technique worked on 140 out of 150 apps. We collected close to 8,000 packets, which consists of over 6,000 TCP flows. First, we perform data types analysis to understand what data types are being sent to the destinations. We found 21 data types that include PII, namely data types that can be linked to a person, fingerprint, namely data types that can be used by trackers to build user profiles, and also VR-specific data types. We also perform ATS, or Asset Tracking Services analysis, to understand the destinations that are being contacted in the network traffic. Here we found that the top 3 destinations include Facebook and Oculus as platform parties, and also Unity as the most popular third-party library used by VR app developers. So together, these analyses allow us to extract data flows and the context. The key takeaways here are that Oculus, relative to other similar platforms, is a young ATS ecosystem whose data collection practices include sending 21 data types to various social or analytics tracking domains. And during our experiments, we did not find on-device ads yet. So after we collect the network traffic, we extract the data flows and the tuple elements. We want to perform a full auditing by also comparing the data flows from network traffic and the collection statements from the privacy policies. So the second part of OVRseen is privacy policy analysis. In privacy policy analysis, we start by collecting privacy policies from first parties, namely the apps, platform parties, namely Oculus and Facebook, and third parties such as Unity. First, we found that many apps, namely 27% of them, did not provide a privacy policy. When they do, we performed automated policy analysis to check the consistency between the data flows and the collection statements. Here, OVRseen makes another main contribution in the policy analysis part by integrating state-of-the-art tools such as Polycheck and Polysys and adapting them for VR. To understand more how this policy analysis works, let's take a look at this example that we have seen before on the Beat Saber app. So suppose that we have collected the network traffic, and we could find a packet structure as shown on top and a policy text as shown down below. And we wanted to extract the tuple elements. Using Polycheck, we can check the consistency of the first 3 elements that we can extract from the packet metadata and payload, and also from the policy text using NLP techniques. In this example, we can see that the 2 tuples, they have exact matches for the elements, and so we consider them as consistent. However, OVRseen deals with data types and recipients that can be expressed in more specific terms in the network packets, but they can also be expressed in more generic terms in the privacy policy texts. And so to map these different terms, we rely on ontologies. The data ontology maps the more generic terms as found in the privacy policies into more specific terms such as the 21 data types found in the network traffic. So for example, in this tuple that's extracted from the privacy policy, it contains technical data as the data type, which is a more generic term for device ID. So we can map technical data into device ID, and this tuple that's extracted from the network traffic. We consider this as vaguely matching, but they're still consistent. We also rely on entity ontology for similar purposes for entities, and we created these ontologies based on the original ontologies created for Android. Upon extracting the data flows and collection statements, we can use Polycheck to check the consistency between the data flows and the collection statements. We call this network topology consistency analysis. whereas where OVRseen determines that the two tuples are consistent if they exactly or vaguely match, and they're inconsistent otherwise. This figure shows our results. The numbers represent the numbers of data flows, whether the data flows are consistent or inconsistent. We found that 70% of data flows are inconsistent with their collection statements in the privacy policies, mainly for fingerprint and VR sensory data types. Upon investigating further, we found that many privacy policies from apps did not reference platform and third-party policies, whereas a lot of the data flows are being sent to platform and third-party destinations. And so upon including these privacy policies from platforms and third parties by default, we found that 74% of data flows became consistent. So the key takeaways here are that many of the developers' privacy policies are missing. If they exist, they're poorly written, and they neglect referencing third-party policies. Finally, OVRseen also integrates policies for purpose extraction by mapping the sentences that are analyzed by polycheck into their corresponding text segments that are labeled by policies with purposes. By doing this, we can extract the tuple elements, including the purpose. Our results show that close to 70% of the data flows are for non-core functionality, whereas only around 30% of them are for core functionality. And so I have presented to you OVRseen. To conclude, I have presented to you OVRseen, a system and framework for auditing privacy in VR from a combined network traffic and privacy policy perspective, whose technical contributions include binary analysis for decryption and the integration of state-of-the-art tools for policy analysis. On the network traffic side, we found that the ecosystem sends 21 data types to various destinations, including VR sensory data types, and Oculus is relatively a young, centralized, and ad-free ecosystem. On the privacy policy side, many apps did not provide a policy. 70% of data flows are inconsistent because a lot of them did not reference platform and third-party policies. And close to 70% of data flows are for non-core functionality. We also responsibly disclosed our findings to developers and Oculus. 24 developers responded, mostly with positive feedback, saying that they're in need of tools to help them be more compliant with privacy laws in terms of data collection practices. Unfortunately, we did not receive any response from Oculus. Thank you very much for listening. The code and datasets are available, and I'm happy to take your questions either here or on Slack or through emails.